In the last few years, we've discovered quite a lot of really cool things about Mars, and one of them was that apparently there is still some liquid water left on Mars, even though it's technically in very salty form. And we've also learned that Mars used to have a very large ocean that is indicated by the tsunami signs that we've discovered on this beautiful planet. As a matter of fact, there were at least 2 mega tsunamis, and I've talked about this in one of the previous videos. But in this video, we're going to talk about, so what kind of environment does Mars need to have liquid water? And is it actually possible to create it today? Welcome to What the Math. And if we look at our solar system, we'll realize that Mars is actually on the outskirts of the so-called habitable zone where liquid water is possible because it's relatively close to the sun, but not far enough for it to be ice, not close enough for it to evaporate forever. Venus is actually within the inhabitable zone, technically, so it should not have water. Earth is just sort of in the middle-ish. And Mars is as well, so is it possible for us to create conditions on Mars where it would actually have liquid water? Let's find out. Let's make an assumption that following Elon Musk's suggestion, we send like, I don't know, 100 different nuclear weapons to the northern pole and the southern pole here, detonate them and create a bunch of liquid water that is possibly deposited there, although it's actually possibly also CO2 ice, but it might be water ice as well. So in other words, let's just say we somehow decided to, or found a way to deliver all kinds of water on this planet, and we'll simulate this by basically, let's just collide Halley's Comet, because this is technically how it happened before. A bunch of asteroids collided with the planet and brought water with them. So we know for a fact that Mars had liquid water, and it was probably from the collision with various asteroids. Alright, so let's say that Mars has now acquired liquid water. And so you can kind of see some of the deeper craters on Mars getting some water here. We're going to add a little bit more. Nah, that's a little bit too much. Can I get somewhere in between that? Okay, and here we go. So this is the amount that's about 100 times less than it is on Earth. And basically we have a very large ocean-like structure, which is basically just all ice in the north here, and I guess that's north, and a bit of it in the south as well. And that's mostly because Mars is actually not a perfect sphere. It does have a very unique shape where the northern part is actually much lower and much smaller than the southern part. Alright, so this is actually kind of similar to what the original ocean was like as well, and we know all of this based on the tsunami leftover marks, which I've talked about previously in one of the previous videos. And so, how do we make this liquid? Well, first of all, we need to know something about the liquid water and ice and obviously water and gas format. And here we need to look at something known as the phase diagram, also sometimes known as a triple point graph. So here it is on the screen. And what you can see here, it sort of shows you the conditions needed for liquid water to exist. And so current temperature on Mars is minus 50 degrees Celsius. The lowest temperature that we can have for liquid water to exist is actually minus 22 degrees Celsius, but for this to happen, the atmospheric pressure, and here we're talking about, let's just say in Earth atmospheres, so this number right here has to be 2070. In other words, we need to have atmospheric pressure that's about or more than 2000 times higher than atmospheric pressure on Earth. It is very unlikely that Mars ever had that kind of pressure. So for it to actually have liquid water, something else must be true. And the only other way for liquid water to exist is obviously Mars has to have had basically warmer temperatures. It had to be much warmer. Now, how could it have been warmer? Well, the only way is obviously if it had more atmosphere. So we're going to increase atmospheric pressure and make it atmospheric pressure of Earth right now. So it's going to have exactly 1 atmospheric pressure on the surface. And let's just see how warm it gets from that. So we're basically turning Mars into a terrestrial planet, into Terra-like planet. In other words, we're terraforming it, making it very similar to Earth, but let's just see if it actually gets the same temperatures. So I'm going to wait a few years, a few in-game years, or at least a few months to see how high the surface pressure gets. And I can actually go into the climate here, and I'm actually going to go into magnetosphere and give it a little bit of magnetosphere so that it doesn't actually lose anything, because we want to maintain all of this atmosphere we've given it, so it's going to have a lot less mass loss and not lose its atmosphere, which is why actually it lost its atmosphere to begin with, because it had no magnetosphere and all of the oxygen kind of just evaporated because of the interaction with solar winds. Alright, so let's just wait a little bit. And interestingly, in this game, if you give Mars these particular properties, you will actually also receive a greenhouse effect of 149 degrees Celsius. Now, to me, this sounds a little bit too much. If you look at Earth, the greenhouse on our planet is 30.5 degrees. On Venus, it's obviously much higher, but Venus also has a much higher pressure. So with the pressure of 91 atmospheres, you'll get a greenhouse effect of 546 degrees. But with atmospheric pressure of 1 atmosphere, we shouldn't really have this much. But for some reason, at least in this game, the atmospheric pressure creates a very high greenhouse effect on Mars, which is why right now I think it will actually warm up to the point where we'll have liquid ocean. So let's see if this actually happens. And here we go. The temperature is above the melting point of water, and I think in a few seconds we'll start receiving a very large liquid ocean on the surface of Mars. Alright, well that's I guess nice, but is it realistic? Because the temperature here keeps climbing, and the atmospheric surface pressure of 1 atmosphere that we gave Mars seems to be overheating this planet a little bit too much. As a matter of fact, the temperature is already at 30 degrees Celsius and it keeps climbing up. So this doesn't really seem very realistic. We need to try to analyze this again. So what would the actual greenhouse effect be here? So is it possible that the greenhouse effect was this high? Well, yes it is, if Mars had a lot of CO2 on the surface and a lot of other greenhouse gases like methane, for example. In that case, maybe it was this high. I think it actually dropped a little bit to 141 now. Maybe it was this high. Maybe it was possible for Mars to have liquid water this far from the sun if it had a lot of greenhouse gases. But the more realistic version is that it didn't really have as much. And chances are the greenhouse effect here was much lower. I would even say it was possibly lower than what we have on Earth right now. And on our planet Earth, the greenhouse effect is somewhere around 31 to 32 degrees Celsius. So let's try to decrease this to basically the same greenhouse effect as what we have on Earth. Alright, and now let's see how cold it gets on the surface here. So we're going to run this a little bit longer just to see what happens to all of this stuff, to all of this water and all of this stuff on the surface. And look at that, it's dropped down to minus 30 degrees Celsius. So, alright, if we had the same greenhouse effect on the surface of Mars as we do on our planet Earth, it would basically be minus 30 degrees Celsius. But liquid water cannot exist in these conditions, so two things are likely here. One of those things is that, well, maybe Mars had a really high atmospheric pressure and also quite a lot of greenhouse effect, which is why it had liquid water. So that's one possibility. So it had very thick atmosphere with a lot of greenhouse effect. But there's also a second possibility, and this is something that I'm slowly starting to possibly consider as a very likely possibility. It relates to something called planetary migration. For example, we know that Jupiter used to be somewhere farther out in the solar system. It's one of the reasons why when it came closer to the asteroid belt, many asteroids disappeared and they actually crashed into other planets. And we also know that Uranus and Neptune used to be much closer to the sun, and then they drifted away. So what if that's something that happened to Mars as well? What if Mars was actually much closer to our sun? So let's just assume that basically it has the same greenhouse effect as here, but we're going to move it much closer to the sun. What if it was actually right between Venus and Earth, essentially right in this region where the habitable zone starts and where liquid water becomes a possibility? Well, in that case, it looks like Mars is once again warming up, and look at that, it's actually going to once again get liquid water. I don't know how hot it's going to get, but having a low atmospheric pressure and also low greenhouse effect still creates liquid water had Mars been a lot closer to the sun. As a matter of fact, it's now closer to the sun than the Earth and has a temperature relatively similar to what it is like on Earth, maybe a little bit hotter. So, alright, so that's actually very interesting. This of course raises a few questions as well. So first question is it possible that Mars actually was a lot closer to the Sun? The answer is yes. And the second question is, so what happened? Why is it so farther away now? Why did it actually get transferred to the other region, basically where it is right now? And the answer to this lies in the idea of the mysterious missing gas giant that used to be somewhere between Mercury and the Sun. What if that gas giant actually kicked Mars out earlier in the existence of our solar system and actually reshuffled many of these objects as well? In other words, it's quite possible that there was quite a lot of planetary migration going on in the earlier solar system, and so it's possible that Mars wasn't really where it is right now, and Venus was somewhere else as well, and so was Earth. So it's quite likely that many of these planets actually changed their positions many times in early solar system. But obviously this is just a speculation, and obviously there's no proof as of now, and we don't really know if this is actually what happened. What we do know is that yes, it did have liquid water, and yes, you do have to have warm temperature for liquid water to exist. And the only way for Mars to have liquid water and warm temperature is either if it has a lot of greenhouse gases on its surface. In other words, if we actually have Mars in its original position, it needs to have a huge amount of greenhouse gases to have warm temperature because it's kind of far away from the Sun. Or it was much closer to the Sun and had greenhouse effect relatively similar to Earth, and in that case it could also have had a liquid water. And obviously as it drifted farther and farther away from the Sun to where it is right now, and also as its core cooled down and its magnetosphere slowly disappeared and then completely disappeared when the metal core of Mars stopped spinning around, that's when it essentially started losing all of its atmosphere, cooled down to the point where it is right now, and essentially lost all of its liquid water. And because it also lost its atmosphere and because of the interaction with the Sun, it then also lost a lot of its ice water as well, eventually becoming what it is today, this beautiful but barren planet. Anyway, that's all I wanted to talk about in this video. It was a little bit of a speculation on my part, but I thought it would be interesting to discover what conditions we need to have for Mars to have liquid water. I hope you learned something from this video, and I hope you enjoyed watching it. And if you did, don't forget to subscribe, don't forget to share this video, and like it if you've enjoyed watching it. I'll see you guys in the next video where we'll do something else related to space, science, math, or possibly play a video game. Game you later, guys, and as always, bye bye.